Hi guys, welcome back to the channel. In this video we are going to discuss the introduction to the shift registers. So let's get started. So in the previous videos we have discussed the flip-flops, that is SR, JK, D and T. These and all flip-flops can store only one bit of information. But if you consider the real world applications that uses multiple bit of information to be stored in them, and like 16 bit, 32 bit, 64 bit, like our mobile phones, laptops, any of the thing. So might be current scenario you might be using 64 bit. So this is the huge memory chunks. With the only single flip flop you cannot have anything. So for that reason only we are going to cascade the n flip-flops so that we can have the storage of n-bit binary information, and it can store n-bit information, and this is known as n-bit register. So this kind of cascading is known as register. So first of all we need to understand the 4-bit register. If you cascade the 4 D flip-flops in this fashion and synchronize with the clock, so this is very basic 4-bit register. In the registers, we generally use the D flip-flops because whatever the input using, the same input will be present at output. So that is very convenient to use the D flip-flops. And step by step we will go. So practically this 4-bit register is no use. Means it is not used because if you pass the clock as 1 GHz, that means the time period of clock would be 1 nanosecond. And master clock is different between different digital clocks. So if you in this 4-bit register, the master clock is same for all the flip-flops. So that is not the consideration. And that is 300 microseconds for register 3. Suppose if you are present in register 3, the information that you also want to have in the register 1 and register 4 too, but we cannot able to access them because we are only in register 3. So this is the modification of the 4-bit register for the master clock. So if you observe the same thing, all would be the same, but we have just changed the clock. So the clock is attached with the load AND gate, that is. So that AND gate output is directly given as clock to the 4 flip-flops, the register. Now we will understand the logic behind that, why we modified the circuit. If you see the load is equals to 0 suppose, so the clock is high. So the suppose load is 0, then the output will not be produced from the AND gate. So clock would not be passed. So register will retain its previous state. So whatever the output of the register, the 4-bit register, so the same outputs would be present in the next state also. If load is equals to 1, the clock is high, so then clock would be passed to the NAND gate and it is applied. Then as it is clock passed, register will follow the clock outputs. Means whatever present state will be passed as the next state. Means normal function of the 4-bit register. So in this scenario we can control the clock signal with the help of AND gate, and we can have our according to our requirement we can change the outputs. So in the general case or the practical applications, this 4-bit register also not used because due to propagation delay of the AND gate, the clock will be propagation delay would be high. So that is the reason, one of the reasons that we are not going to use this circuit. Or the second thing is anything which controls the clock is not used in sequential circuits. So what does that mean? So we are controlling the clock with the help of the AND gate and load. So we should not control the clock. If controlled clock means it is not properly generating the output. So instead of controlling the clock, we can control the inputs because B1, B2, B3, B4 are inputs, right? So we can control the inputs by changing the modification and removing the clock in the AND gate. So this is the modified circuit of the 4-bit register. So if you observe clearly, when load is equals to 0, register will follow the clock. When load is 1, register will retain its previous state. By seeing the circuit, you might be confused how we have to remember the circuit, or it is very big. Guys, one thing I will say that the circuit is very easy to remember. So you see everything, every pattern is repeating. For the first flip-flop, what we have, the second flip-flop also the same thing. If you observe the inputs, that is B1, B2, B3, B4 are taken externally the same way, and the load is taken the negative also. Load is taken negative also. So I will explain the logic now so that you can understand very much far better. So I will only explain the logic for the first flip-flop. So the same thing, the pattern is repeating, right? So that you can apply to the remaining flip-flops also. So if you see for the first flip-flop, when load is equals to 0, I am considering the first case that load is equals to 0, register will follow the clock outputs. Or we can simply say the load is applied, the external input is applied, that is B1 is applied, I can say. So how B1 is applied? So let's see that. So see clearly that load is equals to 0. The blue line is highlighted that. So for the second AND gate, the load is 0. The 0 will be passed. So that gate would not be, that means that input, that side would not be working because the AND gate input is 0. So basically the Q0 is passing one of the input for the second AND gate. So Q0, the previous state would not be considering. So the coming input, the new input, that is B1, when 1 means load bar is 1, right? So that is the reason that we can able to pass the B1 to the flip-flop, the first flip-flop. So that is the reason we can say when load is equals to 0, register will follow the clock, or we can simply say we can load the external inputs. The next case is when load is equals to 1. When load is equals to 1, register will retain its previous state. So what is meant by that? So when load is equals to 1, the blue line is active. So that is meant the second AND gate would be active. So the load bar is 0. So the red highlighted one is 0. So the first AND gate would be 0 definitely. Output would be 0 of first AND gate. So B1 would not be entering the first flip-flop. Means the external input is invalid here or not entered in the first flip-flop. So the previous state, that is Q0, is entering the flip-flop again. So we can say the previous state retained. So like that the 4-bit register logic works. So likewise similarly you can also apply for the remaining flip-flops also. You can observe the same thing is repeating pattern for all the flip-flops. And one more important thing, you can also apply clear bar, that is the active low input you can apply once, and you can take or you can have all the flip-flops at a time. You can start with the 0 and you can pass the inputs one by one and you can check out that 4-bit register. And this is the block diagram for the 4-bit register. So you can have a load, you can have a clock, clear bar, that is active low. So B1, B2, B3, B4 inputs, Q1, Q2, Q3, Q4 as outputs. So simple block diagram. So up to now I have mentioned only the register, but now we are going to understand the shift register. So register is that thing, that difference between, I will say now only. So this is the shift register. So a register capable of shifting the data between the next flip-flop in a selected direction is called the shift register. The output of one flip-flop is connected to the input of the next flip-flop. So you can see the outputs or how it is moving to the next flip-flops, or you can see the blocks, the block diagram also with the arrow indication. The outputs are moving in such a way that moving to rightward. So the difference between register and shift register is, so if you observe in the register, this is the diagram. So each and every output I have highlighted backside as box. You can observe that near Q0, Q1, Q2, Q3, that all the inputs are not connected. Means the Q0 itself is a Q0 output and it is not separately linked with the D1. Means we are not passing the Q0 output to D1. It is Q0 is separate, Q1 is separate, Q2 is separate, Q3 is separate. All the outputs are separate. They are all the inputs are separate, like that I can say. There is no relation between each flip-flop. There is no shifting between the outputs of one flip-flop to another flip-flop. So that is the register. Whereas if you consider shift register, we can have the movement because the output of previous flip-flop can be connected to the next flip-flop input, so that the movement of outputs will be generated. So we can have the two input, means we can have the 2 input sequence, that is serial in. We can have the inputs in the serial way. So that is known as serial input. So for the loading all the input, we need to have the 4 clock cycles. So the next loading is parallel loading. We can load all the inputs to the 4 flip-flops in such a way, in parallel way. So that is known as parallel input. In one clock cycle only we can load all the inputs to the flip-flops. So after loading we have to retrieve the data. So we can retrieve the data in 2 methods, that is serial out. So for retrieving the data in serial out, we need to have 4 clock cycles. And the next way is retrieving the data in parallel out. All the outputs are retrieved in a single clock cycle in a parallel out manner, as you are seeing with the arrows. So based on all the things, we can have the shift register in 4 categories, that is serial in, serial out, SISO, serial in, parallel out, SIPO, parallel in, serial out, PISO, parallel in, parallel out, PIPO, PIPO. So that is the 4 methods that we are going to see in the upcoming videos. These 4 methods are very important, and shift registers have some other applications also. In the separate video we are going to see the shift register applications also. So stay tuned. I hope you understood this video. Thanks for watching up to now.